guys, so today we're going to be looking at 2018 AMC 10A's number 24. So the problem says triangle ABC with AB equals 50 and length AC equals 10 has area 120. Let D be the midpoint of length AB and let E be the midpoint of length AC. The angle bisector of angle BAC intersects length DE and length BC at F and G respectively. What is the area of quadrilateral FDBG? Okay, so hopefully in solving this problem we can learn more about angle bisectors. So here I drew the triangle ABC. Obviously it's not drawn to scale, and our goal is to find quadrilateral FDBG. Okay, so first off, before we get into angle bisector formulas, we can notice that AED triangle and triangle ACB are similar because they share the same angle and their sides are corresponding lengths. Okay, so we notice that the angle bisector of BAC is included in this problem, and we're going to have to use the angle bisector theorem. So here I have it drawn out. Basically, the angle bisector theorem states that if X is the angle bisector, then A over D equals B over C. In other words, B times D equals A times C. So this theorem is what we're going to be mainly using to solve this problem. There's another formula commonly associated with angle bisectors. If we call this length X, then X squared equals AB minus CD. So obviously this isn't the easiest to remember and it's not as commonly used as this first one, but it's still good to keep that in mind. Okay, so now let's, using this, let's solve the problem. Okay, so now let's actually tackle this problem. Here I drew the height. I have length BG equals X and length GC equals Y. Again, our goal is to find the area of quadrilateral FDBG. Okay, so first off, let's keep in mind that the area of this quadrilateral is going to equal the height times this length plus this length divided by 2. Okay, so that's how we calculate the area. Again, this triangle ADE and triangle ABC are similar. They have a ratio of 2 because 5 times 2 is 10. Okay, so keeping what we just did in mind, the angle bisector theorem, we know that 50 over X equals 25 over Y. So 50 over X equals 25 over Y, we just covered. Oh, my bad. I meant 10 over Y. Okay. 50 over X equals 10 over Y. 50Y equals 10X. 5Y equals X. Okay, so now that we have that, I'm just going to erase X and substitute it with 5Y. Okay, so now keep in mind that triangle ABC has area 120, which means that the sum of y and 5y is 6y times h divided by 2 equals 120. So 6yh equals 240. I'll just write it up here. H equals 240 over 6y. In other words, 40 over y. Let me just highlight that. So now we know what the height equals. Because the height of this quadrilateral is h over 2, then we know that the height of this is 20 over y. We know that this length equals 5y. This length is, we can calculate FD given this. It's just 5y over 2 because, as I said before, these two triangles are similar. Okay, so with this we can calculate the area. So the area would equal 5y over 2 plus 5y, the quantity of this times the height, 20 over y, divided by 2. Okay, so let me just erase this so I have space. Okay, so 15y over 2 times 20 over y over 2. As you can see, the y's cancel out. This equals 15 times 20 over 4, in other words, 15 times 5. So we know that the area of quadrilateral FDBG equals 15 times 5, or 75, and that is the answer, and that is D. So I hope that today we learned more about angle bisectors, the theorems, and we also were able to solve this problem using what we learned. Thank you.